gesture-driven interface at 60 fps issue GS-driven animations are occupying the bridge traffic and slowing down the application. Mobile users are used to smooth and well-designed interfaces that quickly respond to their interaction and provide prompt visual feedback. As a result, application have to register a lot of animation in many places that will have to run while other work is happening. As we know from previous section, the amount of information that can be passed over the bridge is limited. There's currently no built-in priority queue. In other words, it is on to you to structure and design your application in a way that both the business logic and animation can function without any disruption. This is different from the way we are used to performing animation. For example, on iOS, the built-in APIs offer unprecedented performance are and are always scheduled with appropriate priority. Long story short, we don't have to worry too much about ensuring they are running at 60 fps with React Native. The story is a bit different. Do not think about your animation top down beforehand and choose the right tools to tackle this challenge. You are on track to run into drop frames sooner or later. Janky or slow animation affect the perception of the app, making it slow and unfinished. In today's sea of application, providing a smooth and interactive UI might be one of your ways to win over customers who are looking to choose the app to go. If your application fails to provide a responsive interface that works well within user interactions such as gestures, not only may it affect new customer but also decrease the ROI and user sentiment. Mobile users like the interfaces that follow them along and that look top notch and ensure the animations are always running smooth is fundamental part that builds such an experience. Solution: if it's possible, use native and correct animation. One of animations enabling the usage of native driver is the quickest way of quickly improving your animation's performance. However, the subset of style props that can be used together with native driver is limited. You can use it with non-layout properties like transform and opacity. It will not work with color, heights and other. Those are enough to implement most of the animations in your app because you usually want to show or hide something or change its position. For more complex use cases, you can use the React Native Reanimated library. Its API is compatible with basic animated library and introduces a set of fine-grained control for your animation with a modern hooks-based interface. More importantly, it introduces the possibility to animate all possible style props with the native driver, so animating height or color will no longer be an issue. However, transform and opacity animation will slightly be faster since they are GPU accelerated. You can play with different combination in this reanimated playground. Gesture driven animation: the more desired effect that can be achieved with animation is being able to control animation with a gesture for your customer. This is the most enjoyable part of the interface. It builds a strong sentiment and makes the app very smooth and responsive. Plain React Native is very limited when it comes to combining gestures with native driven animation. You can utilize scroll view, scroll events to build some things like a smooth collapsible header. For more sophisticated use cases, there is an awesome library, React Native Gesture Handler, which allows you to handle gestures natively and interpolate those into animations. You can build a swipeable element by combining it with animated while it will still require JS callbacks. There is a remedy for that. The most powerful pair of tools for gesture driven animation is using gesture handler combined with reanimated. They were designed to work together and give the possibility to build complex gesture driven animation that are fully calculated. On the native side, reanimated API supports synchronous JavaScript execution on the UI thread using the concept of worklets. The library's runtime spawns a secondary JS context on the UI thread that is then able to run JavaScript function in the form of said worklets. Now, using your imagination and leveraging reanimated, you can create wonderful animation at full available speeds. Low level handling of gestures might not be a piece of cake, but fortunately there are third party libraries that utilize the mentioned tool and expose the prop callback node. It's an animated dot value that's derived from a specific gesture behavior. Its value range is usually from 0 to 1, which follows the progress of the gesture. You can interpolate the values to an animated elements on the screen. A great example of the libraries that expose callback node are Reanimated Bottom Sheet and React Native Tab View. Giving your JS operations a low priority, it's not always possible to fully control the way animations are implemented. For example, React Navigation uses a combination of React Native gesture and animated, which still needs JavaScript to control the animation runtime. As a result, your animation may start flickering if the screen you are navigating to loads a heavy UI. Fortunately, you can postpone the execution of such actions using interaction manager. In the near future, you will be able to achieve similar behavior with React itself on the renderer level with Fabric using Start Transition API. The Sandy React Native module allows you to execute any code after running all animations are finished. In practice, you can show a placeholder, wait for the animation to finish, and then render the actual UI. It would help your JavaScript animation to run smoothly and avoid interruption by other operations. It's usually smooth enough to provide a great experience. So yeah, that's it for today's video. We will next check next animation part in the next one. Thank you. Bye.